Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download this practice lab from the link in the description, and try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better. You can use it up to CCNP level even, whereas Packet Tracer is too limited to do much beyond CCNA level. Here, you can see all of the labs available for NetSim for CCNA. These are all detailed, guided labs that not only help you practice what you've learned, but really test your understanding. So I think NetSim is a fantastic study tool for the CCNA. If you want more practice relevant to what we're covering now at this point in the course, look here in the Network Access section. VLANs, trunking, this is all stuff you've been studying over the past few videos. Make sure to stick around to the end of this video for a preview of one of these labs. If you want to grab a copy of NetSim for CCNA, follow the link in the video description. I highly recommend it. Okay, let's get started with today's lab. First off, all of these devices are pre-configured, so they are like they were at the end of day 17's lab. Except switch 2 has been replaced with a layer 3 switch, aka multi-layer switch. So all of these hosts are already in the correct VLANs, switch 1 and switch 2 are connected with a trunk, and R1 and switch 2 are connected using router on a stick. So what we'll be doing is changing this router on a stick configuration to do inter-VLAN routing via SVIs on switch 2, just like in the lecture video. Step 1 is to replace the router on a stick configuration with a point-to-point layer 3 connection. I'll start on R1 first. Enter privileged exec mode with enable, and then let's do a few show commands. First, let's check the running config of G00 and its interfaces. Show run. By the way, you can press enter to scroll through the running config one line at a time, or the spacebar to scroll one screen at a time. So the physical interface itself has only the default configurations. All I've done is enable it with no shutdown. Under it, you can see the 3 sub-interfaces. Let's check the status of the interfaces. Show IP interface brief. G00 and its sub-interfaces are all up. Now let's remove the sub-interfaces. Enter global config mode with conf-t. Then delete the sub-interfaces with this command. No interface G00.10. Then hit the up arrow, and let's change this to .20. And one more time for .30. Let's check the config again. Do show run. So the sub-interfaces have disappeared. And let's check their status. Do show IP interface brief. Now this is a difference between Packet Tracer and what I showed in the lecture video. When I do the lecture videos, I use GNS3, which runs actual Cisco iOS software, unlike Packet Tracer, which is just a simulator. On GNS3, the sub-interfaces still appear with a status of deleted until you restart the device. But as you can see here, they are immediately removed in Packet Tracer. Now let's configure G00 with an IP address. Interface G00, IP address 10.0.0.194, 255.255.255.252. Okay, that's all we need to do on R1. In the lecture video, I did default interface G00 before configuring the IP address, but that's not actually necessary since it already has the default settings. Okay, next let's configure switch 2's G102 interface. Enter privileged exec mode with enable, and let's check the config of G102. Show run. There it is. Notice this layer 3 switch requires the switch port trunk encapsulation.1q command. The model of switch used in the previous lab didn't require this. Okay, let's return the interface to the default configuration. Enter global config mode, conf-t. Then default interface G102. When testing this lab out before, I had to do the command twice for it to work. That might be a packet tracer issue, but I'll issue the command once more by using the up arrow. And next, let's check. Do show run. Okay, so G102's configurations have been removed. Let's configure it. Interface G102. Let's try to add an IP address. IP, then I'll use the question mark. Notice there is no option for address. Why is that? It's because this interface is still in layer 2 mode. Let's put it into layer 3 mode. No switch port. Okay, let's try again. IP, then question mark. Now we have lots of options here, including address. So let's set the address. Address 10.0.0.193, 255.255.255.252. Finally, let's configure the default route here on switch 2. Exit, and let's check the current routing table. Do show IP route. No routes appear, even though we should have connected and local routes for the interface we configured. Why is that? It's because we haven't enabled IP routing on the switch yet, so let's do that. IP routing. And let's view the routing table once again. Do show IP route. Notice that only a connected route appears, no local route. When I showed you the command in the lecture video, both routes appeared properly, connected and local. So I think this might be an issue with packet tracer. A local route should appear here too. Anyway, let's configure that default route. IP route O.O.O.O, O.O.O.O, and the next hop is 10.0.0.194, R1's address. Do show IP route. Okay, the default route has been added. That's all for step 1. Step 2 is to configure the SVIs on switch 2. First off, let's check if the necessary VLANs exist. Remember, an SVI won't have a status of up if its VLAN doesn't exist. Do show VLAN brief. Okay, VLANs 10, 20, and 30 exist. Let's configure those SVIs. It's fairly simple. Interface VLAN 10. Okay, the SVI has been created. Now all we have to do is assign the IP address, the last usable address of the subnet in this case. IP address 10.0.0.62, 255.255.255.192. That's it. Let's do VLAN 20. Interface VLAN 20. IP address 10.0.0.126, 255.255.255.192. Finally, VLAN 30. Interface VLAN 30. IP address 10.0.0.190, 255.255.255.192. Exit. Now let's check if the interfaces are up. Do show IP interface brief. Okay, looks good. The VLAN 10, 20, and 30 SVIs are all up. So our inter-VLAN routing should be functioning now. Let's test by pinging between VLANs. I'll do a ping from PC7 in VLAN 10 to PC3 in VLAN 30. First, in real-time mode, I'll test the ping. Ping 10.0.0.129. Okay, so the ping gets through. I still get questions sometimes about why the first 1 or 2 pings fail. That's because PC7 needs to ARP for the MAC address of its default gateway. I've explained ARP in a previous video. Now let's go into simulation mode to make sure the traffic is not routed by R1, but instead by switch 2. And let's try that ping again. Ping 10.0.0.129. Okay, notice that the ping goes to switch 2, and switch 2 sends it directly to switch 1, without having to send it to R1. That's because Switch 2 routed it from the VLAN 10 SVI to the VLAN 30 SVI within its own software. Okay, let's return to real-time mode. Finally, just to test if our default route to R1 works, let's try a ping to an address in the internet, 1.1.1.1. Note that I already configured static routes on R1 and the internet router, so you don't have to configure anything else. Let's try that ping. Ping 1.1.1.1. Okay, so the ping to the internet works as well. That's all for this lab. Okay, let's move on to today's NetSim lab preview. The lab I've chosen for today is inter-VLAN routing 2, and I've already loaded it up, so let's get started. The network topology is the same as last time. 1 router, 2 switches, 4 PCs. But instead of setting up the network, we will troubleshoot some problems on the network. So there are 3 lab tasks today. Task 1, verify and correct workstation configurations. These are the PCs. Task 2, verify and correct switch configurations. And task 3 is router configurations. So I think for today's preview, we'll do task 1 and task 2. So task 1, a user has reported that PC3 is unable to ping any other device on the network, including devices that reside on the same VLAN as PC3, which is VLAN 10. Okay, so it looks like the devices in VLAN 10 are PC1 and PC3, and then VLAN 12, PC2, and PC4. Okay, 1 and 3 VLAN 10, 2 and 4 VLAN 12. Okay. Here we are. Okay, and then there's some more explanation. All steps in this task should be performed on PC3. Okay, let's go to step 1. Verify the problem by attempting to ping every other IP address on the network. All pings should fail. Okay, I won't ping every address, but let's go on PC3. Still router 1, sorry. PC3 console. There we go. And let's ping the default gateway, which is 192.168.100.1. This subinterface on router 1. And the ping should fail. Yep, looks like it's failing. Okay, I'll stop that. How about PC1 in the same VLAN? 100.2. Yep, that's failing as well. And let's do one in VLAN 12. How about .130, which is PC2? Okay, so all the pings are failing as expected. Step 2. According to the network documentation, PC3 should operate in VLAN 10. Verify the IP address configuration. Okay. So here is the correct configuration for PC3. Let's see what the actual current configuration is. ipconfig/all. IP address is correct. Subnet mask should be /25, ending in .128, but this is /24, ending in .0. So that is incorrect. The default gateway is correct, however. Okay, so the IP configuration is not correct. Correct any IP address configuration problems you find. So the way to set the IP address for a PC in NetSim is this command here. Note that this is just for PCs in NetSim. ipconfig/IP IP address subnet mask. Okay, 192.168.100.3 and then the /25 prefix length. And let's confirm our configuration. Okay, looks good. Attempt to ping every other IP address on the network. Do all the pings succeed now? Okay, let's do some more pings. How about the default gateway? 100.1. Okay, still fails. How about PC1? Okay, that still fails, and we'll do one in VLAN 12, PC2. Okay, that still fails. I'm using Control-C to stop these pings, by the way. Okay, so we corrected the IP address configuration, but that didn't solve the problem. Okay, it's task 2. After verifying PC3's configuration in the previous task, you should begin examining other devices on the network to determine whether other problems exist. Okay, so step 1, list 2 or more causes of inter-VLAN routing problems on layer 2 switches. Okay, so this is something I really like about NetSim. It really tests your understanding by asking good questions like this. So what are 2 possible problems? Okay, one could be perhaps the PC is in the incorrect VLAN. It's supposed to be in VLAN 10, maybe it's in VLAN 12 or a totally different VLAN. So that's one possible cause. Let's do one more. How about, this is probably a trunk connection between the 2 switches, or it should be. You might have forgotten the switch port mode trunk command, or perhaps the correct VLANs are not allowed. So maybe VLAN 10 is not allowed on this trunk. Therefore, PC3's traffic cannot pass between the 2 switches. Okay, so those are 2 possible causes. According to the network documentation, PC1 resides on the same VLAN as PC3. From PC1 and PC3, attempt to ping each subinterface on router 1. What can you surmise from the results of these pings? Okay. So, first from PC3. Well, we already tried the ping, but I'll just do it one more time. 100.1. This subinterface cannot be pinged from PC3. Did it say both subinterfaces? Yes, each subinterface on router 1. Okay. So the subinterface for VLAN 12 should not work also. .129. Okay, yes, the ping fails. Now let's try from PC1, also in VLAN 10. 192.168.100.1. Okay, the ping works. How about the other subinterface? It works as well. Okay, so PC3 cannot ping either subinterface. PC1 can ping both. So what can you surmise from that? Well, I'd say the problem is either on switch 2 or in the connection between switch 1 and switch 2. Because switch 1 seems to be able to route between the VLANs, no problem. Or switch 1 doesn't do the routing, but router 1 does the routing here. But PC1 can ping through switch 1 to router 1. PC3 cannot though. So there's either a problem on switch 2 or on either switch 1 or switch 2 on this trunk connection here. Okay, next one. On switch 1, display VLAN information. What ports are operating in the same VLAN as PC1 and PC3? Okay, switch 1, console. Enable show VLAN brief is the command we want. So VLAN 10 is the VLAN. Only fast Ethernet 03, which I believe was PC1's VLAN. Yes. So this configuration seems fine. Yeah, so the answer is fast Ethernet 03. On switch 1, display interface trunk information. Which VLAN is the native VLAN and which ports are trunk ports? Show interfaces trunk. Okay, so as expected, fast Ethernet 01 and 02 are trunk ports, and the native VLAN is 1 on both, the default native VLAN. Okay, and then go to switch 2. Okay. Switch 2, enable show VLAN brief. Okay, so no ports are in VLAN 10. Fast Ethernet 03 and 04 are both in VLAN 12. Okay. So let's go to number 6. Based on the topology and IP address configurations, which ports on switch 2 should be operating in VLAN 10? That is probably Fast Ethernet 03. Yes, it is. So here is an issue. PC3 in VLAN 10, or should be in VLAN 10, but it is currently configured in VLAN 12. And its subnet is also the VLAN 10 subnet. So I think we're going to have to change that. There we go. Step 7. What mode is switch 2's Fast Ethernet 03 port in? Okay, so this is a command that I haven't showed you yet. Show interfaces F03 switch port. I don't think I've showed you it yet. Administrative and operational mode are both static access. So this is an access port. It's being configured with the command switch port mode access. So that's the answer to number 7, access mode. Number 8, correct the VLAN configuration. Okay, so that is easy. Conf T, interface F03. It should be in VLAN 10. So switch port access VLAN 10. And then number 9 is verify the new VLAN configuration. Do show VLAN brief. Okay, that's better. Fast Ethernet 03 is in VLAN 10. Next, number 10, on switch 2, display interface trunk information. Okay, do show interfaces trunk. So Fast Ethernet 01 is a trunk. That's correct. Native VLAN is 1, same as switch 1. And I didn't point this out on switch 1, but all VLANs are allowed. The allowed and active VLANs are 1, 10, and 12. So same as switch 1. So the trunk configuration here actually looks fine between the two switches. Okay, next from PC3, do some more pings again. Do all the pings succeed now? Let's see. So first, the default gateway. Okay, the ping works. So it looks like that VLAN issue was the main problem. How about PC1 in the same VLAN? Yep, looks good. How about PC2 in VLAN 12? Okay, it does not work. How about PC4? Okay, PC4 doesn't work either. Okay, so there's definitely an issue there. From PC2, attempt to ping every other device in the topology. Okay, PC2 is in VLAN 12, connected to switch 1. So let's open the CLI here. First, ping its default gateway, 100.129. Okay, PC2 cannot even reach its default gateway. How about PC4 in the same VLAN? Okay, this works. So it can ping the other PC in the same VLAN, but it can't ping its default gateway. How about PCs in other VLANs? It shouldn't be able to reach them because it can't reach the default gateway. Yeah, as expected, it doesn't work. Okay, so clearly we still have an issue here. So PC3 seems to be operating fine, but PC2 can ping PC4 in the same VLAN, but it can't ping its default gateway, which is the subinterface here on router 1. So clearly an issue still remains in the network. So I think we will solve those issues here in task 3, but I'll leave it here for today. If you want to pick up a copy of NetSim for yourself, please follow the link in the description. I highly recommend it. It's great additional practice for your CCNA. And as you can see, there are plenty of labs from network fundamentals, network access, IP connectivity, IP services, security fundamentals. This will give you all the practice you need to get ready for the exam. So again, please follow the link in the description and get a copy. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.